Hey guys, so as promised, this is the video on converting from polar points and polar equations to rectangular points and rectangular equations, and vice versa. So today we'll be using these four equations: r equals square root of x squared plus y squared, theta equals tan inverse of y over x equals r cosine theta, and y equals r sine theta, to help us convert between rectangular points and equations to polar points and equations or coordinates. So as a review, rectangular coordinates are represented by x and y, while polar coordinates are represented by r and theta. And so in r equals square root of x squared plus y squared, we have, as in the picture, this is r. So remember that this is the point in the polar coordinate system, and this is r is the directed distance from the pole. So if we drew an imaginary line from this point to the polar axis, we have our y and our x. And as you can see, this is basically a and b and c in the Pythagorean theorem. So remember that a squared plus b squared equals c squared, which means that x squared plus y squared equals r squared, and therefore r equals square root of x squared plus y squared. And theta equals tan inverse of y over x. Well, we already know this from our trig unit. And more from our trig unit, x over r is basically the adjacent side over the hypotenuse side. So x over r equals cosine of theta. So this means that when we multiply r on both sides, we get x equals r cosine theta. And the same thing for y. Y is basically, y over r is sine theta. So you multiply both sides by r and you get y equals r sine theta. So the first conversion that we're going to be doing is converting from a polar point to a rectangular point, and we'll be using x equals r cosine theta and y equals r sine theta. So if you remember, so this is r, 2 is r, and pi is theta. So what we'll do, our x is going to be equal to 2 times the cosine of pi. And the cosine of pi is, if we use our unit circle, the cosine of pi is -1. So -1 times 2 equals -2. I won't have space here, so I'm going to make this smaller. Sorry about that. And then our y is going to be equal to r sine theta. Our r is 2 in this case, and our theta is pi. So sine of pi equals 0. And you multiply that by 2, and you get 0. So basically, when we convert this to a rectangular point, it's going to be -2, 0. Let's do another example. So x equals, let's make this font smaller, 15. X equals, why is it not? X equals r cosine theta. So our r is square root of 3, and we multiply that by r cosine of theta, which is pi over 6. And if we use our unit circle, cosine of pi over 6 equals √3 over 2. So √3 over 2 times the square root of 3. I thought I'd be needing a calculator, but actually I don't need a calculator, because I can't do the square root thingy here, but actually I can use the square root thingy. So if you see square root of 3 over 1 times square root of 3 over 2, well, these 3's are the square root is gonna cancel out because you're multiplying a square root by square root. So that becomes 3 over 2. And y is equal to r sine theta. So square root of 3 times the sine of pi over 6. Sine of pi over 6 is 1/2, so 1/2 times square root of 3, it equals square root of 3 over 2, which is basically cosine of pi over 6. So our rectangular coordinate is 3 over 2 and square root of 3 over 2. Sorry about that. And we're finished. So the rectangular point to the polar point is a little bit more complicated. So we're going to use r equals square root of x squared plus y squared and theta equals tan inverse of y over x. So our first step, r equals x squared plus y squared. So square root of x squared plus y squared, negative 1 squared, negative 1 squared plus 1 squared. Well, negative 1 squared is just 1, and 1 squared is also 1, so we're taking the square root of 2. And that is our r. So our theta now is tan inverse, let's just pretend that there's an to the negative 1, because I'm not going to do that. Y over x, negative 1 over 1, negative 1 over 1 equals negative 1. So when the tan inverse just means that we are trying to find what angle in radians on the unit circle has a value of negative 1. So if we use the unit circle, the value that has a negative 1 is 3 pi over 4. Now there's also another value of tan, which we get a negative 1, and that is 7 pi over 4, but the only reason we're not going to use that is when we're converting from a rectangular point to a polar point, we have to stay in the same quadrant. So since negative 1, 1 is in the second quadrant, and 3 pi over 4 is also in the second quadrant, we use 3 pi over 4. Because 7 pi over 4 is in the fourth quadrant, we do not use 7 pi over 4. And our second example, 0, 2, r equals square root of x squared plus y squared. So r equals square root of x squared plus y squared, 0 squared plus, which is 0, plus 2 squared, which is 4. So we're taking the square root of 4, which is basically 2. And that is our r value, and our theta is going to be equal to the tan inverse of y over x, which is 2 over 0. Now, instead of doing our tan inverse here, because we can't do this because this is going to be undefined, 2 over 0 is undefined, but we can infer that this is going to be a point on the unit circle where tan is undefined, and since if we use the rectangular point 0 over 2, well, if you picture that, that's on the y-axis. It's 2 units above the pole. So we can just assume that our theta is going to be pi over 2, since that's where 0 over 2 would be. It is also a value where tan is undefined, and it's on the same axis as this point 0 over 2, so our final final polar point is 2 pi over 2. So now we are going to convert from a polar to a rectangular. Last time we did polar to rectangular equations. For equations, we are going to use a combination of these here. So for r equals 2, we know that r equals square root of x squared plus y squared. So this means that r equals square root of x squared plus y squared, x squared plus y squared. And this means that r squared equals square root. So in order to get at the square root of the square root, we are going to have to square both sides. So r squared is equal to 2 squared. And this means that r squared is going to be equal to x squared plus y squared. X squared plus y squared equals 4. And as you can see, we already have our things in terms of x and y. And we don't have to do anything like square root or anything. We can just leave it like this. So for theta equals pi over 3, we know that theta equals tan inverse of y over x. So basically, pi over 3, we're going to set that equal to tan inverse of y over x. And this means that in order to solve for this, we multiply both sides by tan. So tan of pi over 3 equals y over x. And now we just find what is the tan of pi over 3. Well, the tan of pi over 3 is root 3. So root 3 equals y over x. This means that y equals root 3 times x. And finally, our last problem, r equals secant theta. Well, we don't know much about secant theta, but we know about cosine theta. So we're going to convert this to r equals 1 over cosine theta. Now, we know from our equations that x equals r cosine theta. So we're going to try to convert this to have r and cosine theta on the same side. We're going to multiply both sides by cosine theta. So we get r cosine theta equals 1. R cosine theta equals x, so this is x equals 1. And as always, thank you guys so much for watching, and I hope this helped.